All right. Welcome, everybody. Okay, I think we're good. So a couple things. And I just noticed I'm wearing my pink wristband still. So if you have to go on campus because you have other classes, like when you check in, this is the wristband for today. Tomorrow it will be a different color. So, that's just, if you haven't seen it yet, it's just like when you go to a concert or a show or some kind of a thing and they put the little paper band on you. Same thing at the college, except they change up the color every day. And the parking lot was surprisingly full today at 10 o'clock for my 10 o'clock class. It wasn't overflowing like it usually does when, like, the first week of class or whatever, but I was surprised the parking lot was nearly full, which I didn't think it was going to be that full. So just kind of be prepared for that. If you have on-ground classes as well that are resuming with the on-ground portion, there's that. It did look like they were moving people through the pretty quickly through the check-in places where you have to check in and get your band. Although I was there significantly before class. It was like 9:15 or something, or 9:10. So it wasn't at rush hour, but just so you know, in case you have to go do that. Right. Oh, so we have things due. So you've got, oops, I'm looking at the wrong thing here. So you have homework due today, right? It's a lot of that factoring stuff, some rational expressions, rational equations. A lot of that is due today at midnight. And then we already started talking about systems of equations last time, which isn't due for a while. But again, you don't want to be waiting for the due dates if you can at all help it, because that's kind of going to put you behind. I'm putting those due dates so that people have plenty of time to work on it. But if you're waiting till the due date to do it, you should be doing it sooner, really. And that's great. People are putting their names up there. I really appreciate that. When I take roll in a few minutes, that's going to make it much easier. So thank you for doing that. What I do want to ask is if there is any requests for material, I don't want to plow too far ahead into the material that isn't due for a while, but also I don't want to be going over stuff that you don't need to see. So, and be specific. If you have a question, be specific with the question. But is there anything, maybe even from the homework that's due today? Are there any of these sections, rational expressions, rational equations, factoring? Are there sections here that people need to see a few examples of? See me go through and do a few of these, because I'm happy to do a few of these problems and explain what we're doing there. But I kind of need some direction on which things you need to see and which things you don't need to see. In fact, excuse me. Either way, I'm gonna need. Somehow I closed a link that I'm gonna need. This is the one we'll need in a minute.
Yeah, if you can go over rational expressions, that would be helpful.
Yeah, so that's just, there's 2 chapters to that. Do you have specific ones? Like, are there specific of these sections here, ones that you need to see, like multiplying, dividing?
Yeah, I think multiplying would be a good one to start with.
Multiplying for the rational expressions. Okay, so let's take a look at that. Multiply rational expressions. Let's do level 2. Okay, so this is a big one. And it's going to take me a little while to write it up, but that's okay. The important thing is that we're going, so I'm just warning you, it's going to go a little slow for this problem, but the important thing is that you guys get to see them so you know how to go through and do these problems. So we want to fully simplify the expression below and write your answer as a single fraction. So remember with rational expressions, these are really just complicated fractions. Okay, so ultimately they're fractions. When I look at this, what do I see? I see 2 fractions being multiplied together. Now, they are hard fractions. They have polynomials in the fractions. So we get all of the complications that come along with fractions. We also get all of the complications that come along with polynomials. We have all of them in one problem. All right, great. we've got, you know, no, people don't tend to like fractions. They don't tend to like polynomials. So we're looking at both at the same time. But that's okay. We can do this. But we have to kind of break it down and try to make sense of it. So what do we do when we multiply fractions, right? So let's just start off with the simpler part. Whoops, I didn't clear these out yet. Let me get these cleared out. What do we do when we're just dealing with fractions? So let's say we want to take 2/5 times 3/7. Okay, so you can kind of remind yourself, just thinking about it from a basic standpoint. What do I do when I just have fractions and I want to multiply them together? Because ultimately that's what we're dealing with. Well, when I have fractions and I multiply straight across. So when I multiply these straight across, the 2 times the 3, I'm multiplying numerators to get 6, and I multiply the denominators to get 35. Okay, and in this case, what we need to do is look at and ask myself, can 6/35 be simplified any further? Okay, are there, you just start looking for common factors. Well, 6 only has a few factors, 2, 3, and 6. I mean, 1's a factor, but that doesn't do us any good. So it looks like 35 is not divisible by 2. It's not divisible by 3. It's not divisible by 6. So this is a fully simplified fraction. But what we're reminding ourselves of is the fact that we use that same process to multiply these fractions as we do for rational expressions. That is, we multiply straight across. Now, there's a caveat to that, because if I multiply, here we go. If I multiply straight across, I'm going to get a 4th degree polynomial in the top, and it's going to be a big pain to unwind. So we're going to use the same procedure, which is to multiply straight across. However, we are first going to simplify each fraction as much as we can separately, and then we're going to simplify them as a whole, and this will make things less complicated. So almost always with rational expressions, step number 1 is factor every polynomial you see. So I'm looking at 4 polynomials. I need to factor all of those. Okay, just focus on that as step 1. I'm going to focus everything we got. Okay, so let's see. I'm going to, like I say, it's going to take me a minute to write this up, which is totally fine. But just bear with me a minute. Keep hitting caps locks all day. Let's see. Let me pull this out so I don't have to keep switching back and forth. Okay, so we're looking at 4x squared minus 40x. So 4x squared minus 40x plus 64 over x cubed minus 6x squared. Uh-oh. Oh, because I'm not in math mode, I think. There we go. Okay. It was I wasn't in math mode, so it wasn't compiling right. Times. Now we have another fraction. And that other fraction is x squared minus 9x plus 18 over x squared minus 5x plus 6. And I'm going to take a minute here to double check that I got everything written down, because it is a bummer when you spend 10 minutes not getting the right answer and then you realize that you wrote the problem down incorrectly. That's a bummer. Okay, so that's all I've done so far is the original problem. That's all we got is the original problem. All right, but what I just told us was we got to factor everything. Like, we're not even going to worry about multiplying yet. Because if we multiply now, we're going to get really big, complicated things. We want to make things smaller by canceling, and then we'll worry about the multiplication. So let's see about multiplying stuff. Okay, the bottom looks easier. Let me do that one first. So that's just going to be, looks like I'm going to take out an x squared, and that's going to leave me with an x minus 6. Let's see. Now let me look at the top. This one might take me a second. This is one of those complicated ones. Oh, this one can be simplified. Let's see. Looks like we can take a 4 out. Let's do that. I'm going to factor a 4 out of the front. Let's write it this way. Otherwise, I don't want to write so much that I lose people, so let's write it this way. So that's going to be 4 times x squared minus 10x plus 16. Right? 40 divided by 10, 64 divided by 4 should be 16. Okay, so we've got... So this isn't fully factored yet. I believe I'm going to be able to factor this further, but I didn't want to do 2 steps of factoring and then lose people and have people going like, where did that thing come from? So I'm breaking it down into smaller steps to make sure that I don't lose anybody. Okay, and then we're going to have times the fraction. Let's see. So these are going to have parentheses, and on the top we're going to have what? X squared. Looks like maybe 6 and 3, so x minus 6, x minus 3. And I'm doing all the factoring. So at this point, I'm kind of moving quickly through the factoring because that's the other set of homework. So if you have any questions on how I'm factoring these, bring that up as well. Feel free to ask in any of the chats, and we can go over that. Okay, so the bottom one is going to be what? Minus 3 minus 2. So x minus 3, x minus 2. And normally we'd move on to the next stage, except we still have to simplify that first numerator, right? So let me see. What am I going to get out of that? That's going to be... Okay, so if I've got x squared, so that's going to be x and x. It's going to be minus minus. And what do we have? Let's see. Things to 16 that get us 10. 8 and 2? Yeah, it looks like 8 and 2 works. 8 and 2. If I made any mistakes in there, point them out before I waste a bunch of time on this. Okay, so what did we do? We have the original problem that we started off with. And then I did some factoring, but we had a 2-step factoring that needed to occur because this first numerator is not fully factored. I factored out the 4, the greatest common factor. Now my next step, the only thing that's changing is that first numerator, where I went ahead and factored what was in the parentheses as x minus 8, x minus 2. Okay. So now we have everything factored. And that's generally, like I say, step 1 of things when you're dealing with rational expressions and rational equations. Almost always step number 1 is just factor every polynomial in the problem. Okay, we've done that. Now, what we can do is recognize that when we multiply polynomials, we multiply straight across, right? Meaning that effectively this operation that we're doing here really just becomes one giant fraction with all of these factors where we take that c dot out the middle, and in fact we should make this let me put this here, and let me put this here. And then we will get rid of that. Let's see, did I Yep, looks like I got this compiled right. Okay, so what do we have? Well, it's the same thing we did up here when we had these fractions and we just multiplied straight across and ended up with one fraction that had those two things multiplied. Well, that's what we have here. We have one big fraction that has all the factors of these two little fractions, because when we multiply, we're just multiplying straight across. However, what we don't want to do is start using our polynomial multiplication to multiply these terms out. Things are going to get complicated. What we want to do is recognize, wait, I see common factors in the top and the bottom. Why don't I cancel those out? So remember, canceling is where we divide the top and bottom by the same thing in order to simplify the problem. So let's see. I don't see an x minus 8 in more than one spot. I see two x minus 6s, two x minus 3s, and two x minus 2s. So that's a ton of simplifying that's about to occur. So when I simplify this, I've got what? We've got the 4 on top, and then we've got an x minus 8, and then let's see. The x minus 2 is going to cancel, x minus 6 is going to cancel, x minus 3 is going to cancel. So I believe now we just have x squared on the bottom. See, does that look right? Yeah, that looks right to me. Now, there were some directions that they gave us, so let's reread that. What did they tell us? Fully simplify the expression below and write your answer as a single fraction. Okay, so I want to make sure I'm answering the question in the way they want, because I definitely know I see some students where, and I get emails where students are trying to do one thing, but they're missing, let's see, let's get this muted here. Getting some weird feedback there, so I'm just muting. What was I saying? So we've got sorry, I don't remember what I was saying, but we've got we canceled all the common factors. So see how there's an x minus 6 on top and the bottom, so we divided that out. X minus 3 on the top and bottom, divided that out. X minus 2 on the top and bottom, divided that out. Just like we would if you have 8 over 4, you divide the top and bottom by 4. You're dividing out the common factors, right? So let's see. Make sure I put this in the way they want. So fully simplify the expression below and write your answer as a single fraction. Okay, so we've got x squared on the bottom, 4x. So let's go divided by 4 times x minus 8. Oh, and the way I get the fraction bar, shortcuts are nice. I try not to have to. Anytime you have to reach for the mouse, it just takes time. That's why you see people like computer programmers and stuff almost never use the mouse if you look at them. It's because it's faster for them to use the keyboard. So if it can be nice. You just know the way you make a fraction here, you just hit the slash button. Like if you were trying to type out a fraction, you do A / bar and then B, or 3 / bar 2 to make a fraction if you were typing it in an email. If you do that here, the slash makes the line between the fractions. And then on bottom we had what? X squared. And let's go ahead and see. It liked it. I wasn't sure if it was going to like my answer. So you can see what they do here. I mean, it's the same problem we just did. It's literally the problem we just did. But you can see, what do they do? First thing right out of the gate, they factor everything just like I did. Right? So they factor everything. And then now they color code it. You can see the factors matching up. Now, we want to be careful because technically, like right here, we're canceling this blue x minus 2 with this blue x minus 2. And we're canceling this purple x minus 6 with this purple x minus 6. Now, we want to be careful because technically you cannot cancel a factor from one fraction with a factor in another. Right? And I see a lot of people get confused by this when they do the addition and subtraction part of the chapter. They try to do that. They try to cancel something in one fraction with something in another fraction. Well, so why is it written this way if I'm telling you that that's not allowed? Well, it's because of this step right here, where remember we went from this step to this one, where we basically took the two separate fractions and we just put them together as one fraction. So we know they're going to form one big fraction anyways. So that's why a lot of times you'll see people do this where they kind of, technically it's slightly lazy, but these problems involve a lot of writing, and so, we cut ourselves a little bit of a break. Technically, you're not canceling things in different fractions. It's that we're forming one big fraction and then canceling them out in that one big fraction. Don't do it when you get to the addition and subtraction. Excuse me. I see students get very confused by that. Okay. And so we got that one right. So that's how you do those. So fundamentally, we did the same thing you do when you multiply fractions. You multiplied straight across. But we had to factor everything first and cancel out the common factors to make our lives a whole lot easier when we do that multiplication. Okay? So that's helpful. I'm just curious what the next one looks like. Yeah, these are kind of gnarly. Okay? So let's see. We did that one. We had undefined rationals. We'll spend a little time on these. We'll go over these, right? So this is rational expressions. This is like the undefined rationals. So whenever you have a rational expression, you always want to know, where is this thing undefined? Well, remember, a fraction is undefined when the denominator is 0. So our question is, when is x minus 9 equal to 0? So you literally set x minus 9 equal to 0 and solve it. Well, if you set x minus 9 equal to 0 and solve it, you get what? You get x equals 9. So in this case, you go 9. Like in this case, it's a little easier to see because the factor is a 1-degree polynomial. So it's pretty easy to see. What do we need to get 0 in the bottom? Oh, it's going to be 9 for x. That gets me 0. So I submit that. It says yes. It goes great. Some people try to set the numerator equal to 0. That doesn't make the fraction undefined. That just makes the fraction 0. If you set the numerator equal to 0, what you're actually solving for is the x-intercepts. That's different than the undefined points. Okay, very different. Okay, what about this one? This one's not quite as easy. Some of you probably are seeing what that value for x down here would be to get 0, and it's 3, right? You set 4x minus 12 equals 0 and solve that. You're going to get x equals 3. I'm trying to see if they'll give me a specific type of problem, but they must not give that in here. I'm trying to remember. In this case, it's going to be what? Negative 3. Yeah, they're not going to do it. So what if you had something down here that was a 2nd-degree polynomial? Set that 2nd-degree polynomial equal to 0 and solve it. That's from the other part of the homework that's due, right? So make sure that you're comfortable with those. Dividing. What happens when we go to divide? Like, here's a division problem. How are we going to deal with that? Well, again, we fall back on asking ourselves, how do we divide a fraction? When we have fractions, what do we do when we want to divide those things? So let's say we have the fraction 3/7 divided by 2/5. Okay, and I know that most people in the class, when I ask the question, what do we do here, they will at least be able to give me a phrase. Right? Sometimes students don't know what that phrase means. When I go, do you know what that means? They'll go, I don't remember. But most of the time people do remember, and that is invert and multiply, right? People can sort of have that, like, it's like just burned into their brain. They'll never forget it. Invert and multiply. You take the second fraction. Yes, it has to be the second fraction. You flip it, and you change the problem to multiplication. So we would change this. 3/7 divided by 2/5 equals... That would become the fraction 2/5 times what's it going to be, 5/2? So 3/7 divided by 2/5 Oops. I did those in the... What did I do? That doesn't make any sense. This is wrong. Hold on. This should say 3/7. Yeah, there we go. Times 5 halves. So the first fraction stays the same. It's the second fraction that gets flipped. And then you would just multiply right across. And that's going to give us 15/14. So this would be 15/14. And in this case, we would not be able to simplify that. That's the whole thing. So what makes the division problems different than the multiplication problems is just step 1. After you complete step 1, you're doing the rational expression multiplication, which is the one we just did. Right? So basically, if you're doing a division problem, there's one step of prep work to get your problem set up correctly. Once you do that, you do the problem that we just finished a few minutes ago. So let me show you what that would look like. Okay, give me a minute to write all this down again. I'm doing this problem that it's given me for the division. So we've got what? X squared minus 16 over 2x minus 18 divided by x squared minus 2x minus 8 and x plus 2. Okay, so we can see here what it looks like. Okay, so the first thing we want to do is let's change it to multiplication, right? So we're going to get this. I'm going to change this to multiplication. And then we are going to flip this fraction upside down. There we go. So see what I did to get from this line to this one? We changed the division to a multiplication, and the second fraction gets flipped. Not the first one. Okay, the second one. Has to be the second one. You can try it. Try flipping the first fraction and see if it works. You're going to end up with a different answer, which makes sense if you think about it. So that's what we're doing. And then now this problem is just like the one that we did a minute ago. So what are we going to do? We're going to factor everything. Okay, let's see. So if I factor everything, then that means my first fraction. All right, so that numerator is going to be x plus 4, x minus 4. Oops. X plus 4, x minus 4. On the bottom, we're going to have what? I can factor a 2 out, so it's going to be 2 times x minus 9. For our second fraction, x plus 2 is just x plus 2. There's not really anything we can do with that. And then on the bottom, x squared minus 2x minus 8. Believe we can do something with that. So let's see. It's going to be x plus and x minus. So what? X minus 4, x plus 2. Seems right. Okay. All right. Now we're looking at, are there things that can cancel? Well, this x plus 2 here can definitely cancel. Now, think about it. When I use that word cancel, I was saying earlier we should be thinking about the word divide, right? And you go, well, who cares if I say cancel or divide? Well, cancel, people think of canceling as drawing lines through things they don't want to be there. I don't want that. This is too many factors. I don't want them there. I'm going to draw some lines through it. But dividing is an actual mathematical operation. When you divide, you have to think about the division that you're doing. So when we divide that numerator in the second fraction by x plus 2, what are we left with? And I see a lot of students say 0 because the x plus 2 is gone, so it's just 0 that's left. That's if you're thinking of it as drawing lines through things and taking them away. If you use the correct language, which is division, if I divide x plus 2 by x plus 2, I'm left with 1. So really, we should have a 1 in that second numerator. So here we're going to end up with a 1. And that x plus 2 part is gone. Oh, I deleted something here. Okay, so I've simplified the second fraction. Let's look at the first one. Is there anything? Nope, it doesn't look like there's anything here that can cancel. All right, now let's combine them into one big fraction. Remember that step of putting them in one big fraction. Let's give ourselves a little room here. So we're going to put the x minus 4 is going to go here. And we're going to lose the second part. Whoops, where'd my page go? Okay, so see, all I did was take this and combine it into one big fraction, because remember, when we multiply fractions, we're just multiplying straight across. So x plus 4 times x minus 4 times 1 gives us x plus 4 times x minus 4. 2 times x minus 9 times x minus 4 gives us 2 times x minus 9 times x minus 4. So I didn't do anything fancy. We essentially did the multiplication, which puts them all into one big fraction. But sure enough, look, we can cancel the x minus 4s. Great news, right? It's great when we can make things simpler. So that will become the fraction. The x minus 4s are gone, so we have x plus 4 over 2 times x minus 9. And there's our fraction right there that we want. Excuse me. So let's see. Let's see if that's our answer. So we get here. I put my slash sign, and you can see the division bar comes up. There's also a fraction sign if you do the keyboard. Then there's a fraction. Where is it? Somewhere in here there's a fraction. Anyways, it's the slash button if you want to make it when you're over here. So what did we say? X plus 4. And then on the bottom we have 2 times x minus 9. And they want it in simplest form. I think this is arguably simplest form. And there we go. Got it right. And they show us how to do it. Basically the same thing. Flip the second fraction. Change it to multiplication. Factor stuff. Combine it all. Cancel more if you need to. Okay? That's how that works. All right. This is as good a place as any for me to take roll. So let me take a few minutes to do that. So what do we have here? Lots of people with their names. That's great. Okay, great. There's a request for a problem. So yes, I will go over that in just a moment. Let's see. So then we got... Oops. Oh, let's see. No, I had that. Yep. Okay, I think I got everybody. Great, thanks. Okay, so there was a quest for can you review solve linear equations level 2? Okay, so that one would be from the past, right? That's a past due one, solve linear equations. Or were you thinking of the systems of equations, or it was just solve linear equations? So where was that? Oh, systems of equations graphically. Oh, okay, level 2. Okay, solve linear systems graphically level 2. Okay, so there's a request for this one. So let's take a look at that. Okay, so there's really two ways that you should go about graphing these lines. You can either use what you know about the slope-intercept form, which you do want to be comfortable with. Also, you can fall back on just plotting points. So let's move this one. I'm going to move this one out of view, and we're actually going to jump over to Desmos so we can kind of see how we want to do this. So I'm going to graph one of these lines using one technique and one of the lines using the other technique. So you see both techniques for graphing, because really you should be able to do both of them. But at the very least, you got to rely on one to get you through. Okay, so let's first do the y equals x plus 5. And it's going to pop up here, but let's just say we don't know where it is. Okay, so what do? When I look at this, I want to identify my slope and my intercept. Let me make this bold. There we go, a little bigger. Okay, y equals x plus 5. So let's see, what does that mean? That means my slope is 1, because the coefficient on my x variable is a 1. And how do I think about that in terms of slope? How do I think of that? Oh, well, slope is rise over run. And in this case, we can think of it as being 1 over 1 or -1 over -1. Either way, it's going to move us in the right direction, right? One takes you up and to the right. The other takes you down and to the left. So they end up being on the same the same line, just different directions on that line. So this tells me I have a slope of 1. Okay, so once I get a point, I'm going to go up 1 over 1 in the positive direction. That's going to help me. Okay, but where do I start? Well, we've got ourselves here an intercept. So remember your y equals mx plus b. This is your b. That means that a point on your graph is 0, comma b. So 0, 5 is a point on our graph. And you can see that because what happens when you plug in 0 for x? You get y equals 5. So that means that we have the point 0, comma 5. And then remember we said the slope was 1, so that's going to be up 1 over 1. So that would be right here. That point is at 1, 6. And then also, just in case you ever have to interpret the slope the other way, we could think of a slope of 1 as -1 over -1, which would mean we go down 1, back 1, which would put me at -1, comma 4. And look at, they both put us on the same line. So it doesn't matter which you use as your second point, whether it's 1, 6 or -1, 4. They both work, and then you just put your straight line through those 3 points, and you're good to go. Okay. Okay. So now we've got the first line drawn, right? We did this y equals x plus 5 part for the solve the following system of equations graphically on the set of axes below. Okay, so then now when I need to draw it on here, I kind of look, it's the same thing. Okay, it goes through 0, 5, it goes up 1 over 1. So doing that here, I'm going to go 0, 5, that's 1 point, and then up 1 over 1 puts us there, and there's my line. Okay? All right, so that's good. Now what about this other one? We've got 3x plus y equals -7. 3x plus y equals -7. And say we don't know where that is. So how would I go about figuring out this one? Well, I did the slope-intercept form to find out where the first line was. So I said I'm going to use a table and plot points to get this one. So I'm going to add myself a little table here. And I kind of have to fill in these values. But you're just going to pick some x values that you're interested in, right? So let's see. We should, in this case, it looks to me like in order to avoid fractions, if I pick x values that are multiples of 3, I think it's just going to come out a little bit easier. So let me choose some x values I like. How about 0? That should be good. How about 3 and -3? You can pick other values. Some of them might give you fractions, and then you're just going to have to deal with the fractions as they arrive. So let's see. If x is 0, so if I go up and I plug 0 in here for x, let's take this over to the other part. 3x plus y equals -7. Okay. 3x plus y equals -7. So that is our equation that we're working with. 3x plus y equals -7. So when x equals 0, so we're kind of doing this first case right here. Oops. Where am I? Here, where x equals 0. So I'm going to plug x equals 0 into my equation. When I do that, I get the following. 3 times 0 plus y equals -7. Well, 3 times 0 is 0. So this whole thing just becomes y equals -7, right? Y equals -7, meaning that when I come back over here, this point is -7. So I've got, I'm just going to have to zoom out a little bit. We've got a point there at 0, -7. Oops, you can't see it on this one. So, okay. 0, -7. Okay, now we're going to do it for these other values. Let me find when x is 3. Okay, so when x equals 3. Oh, we didn't have to choose multiples of 3. I was thinking about division. That was going to make it cleaner. But in this case, we could have used basically any number we wanted. But when x equals 3, we get, you get 3 times 3 plus y equals -7. Meaning this is giving me that 9 plus y equals -7. So that's going to give me y equals what? -16? Y equals -16. Looks like my graph that I'm going to have to graph over here isn't big enough for that. So maybe I want to choose a different number. And that just happens. You pick a number, it ends up not being a good one, so you pick something else. Whoops, that wasn't supposed to happen. There we go. Okay, so we'll pick some other value. What if I pick, yeah, if I pick -3, that should be better. So let's go. When x equals -3, okay, when x is -3, so we have what? We have 3x plus y equals -7. So plugging that in would give us 3 times -3 plus y equals -7. Or that -9 plus y equals -7. So all told, when we add 9 to both sides, we're going to get what? Y equals 2. So our second point over here should be at -3 should be y equals 2. So we should have -3, 2. Is that right? Let's see. If I plug that in, I get -9 plus 2 equals -7. Yeah. So then we can go ahead, we draw our line through those 2 points that we just plotted. Then we just kind of, when we're transferring it over to the homework, I go, okay, so I've got one at 0, -7, and -3, 2. So let's see if I can reproduce that over here. So 0, -7, and -3, 2, and -3, 2. Oh, and it turns out that point that we found, in just by coincidence, is the point of intersection. So we're able to graph both those lines. The point of intersection is the solution that we're looking for. So let's see. That occurs at -3, 2. Hit submit. We get this, and we're good to go. Okay? So that's how you do that one. And keep in mind, for anyone that's, some people are behind and they're trying to rush through in order to get these assignments completed. Remember, with the systems of equations, checking your work is easier than finding the solution. So checking your work's pretty straightforward. All you're doing is plugging some values in your variable and seeing if it's true. But solving that system of equation can take a little bit more work because you need some more skills in order to make that happen. Excuse me, but that's the process in which we use to make those work, okay? Let me know if there's any other requests for particular problems that you want to see before the homework becomes due. Let's see, how are we on time? Yeah, we're good on time. No requests, no questions on particular problems. All right, let's find, that one's, Trying to figure out which would be a good one to do here that isn't going to take me forever to write it up in the math type, right? So guess we can do this one. Let's go through this one. So we'll solve, we'll solve this rational equation together, and then we'll go through and see what makes sense. Now, looking at this, we already know we're going to have problems when x is 0 or -1, right? Because when x is 0, this fraction is undefined. When x is -1, this fraction is undefined. So we want to look out for values that are going to make things undefined. Okay, and then we'll do factoring trinomials after that. Sounds good. It's a request for that. Okay, so let me copy everything over. Oops, how did that happen? New page. Okay, so what have we got? We've got the fraction minus another fraction equals a fraction. Okay, so we've got this. 4x over x plus 1 minus 5 over x equals 4 over x squared plus x. Okay, first thing we're going to do is figure out the least common denominator. Now, the least common denominator is the smallest thing that all of our denominators divide into. The whole goal here when we do these is to eliminate the fractions, right? Polynomials are hard enough. Now we have fractions of polynomials. What a pain. So let's just eliminate the fraction part. Well, to do that, we have to get all the denominators to cancel. How do we get all the denominators to cancel? We multiply everything by something that is going to cancel out those denominators. So we have to go through and look and figure out, well, what are the factors that I need to cover all these denominators? Well, we don't really know because they're not all factored. How can we know the factors if we haven't factored everything? So what we need to do is go through and factor, right? That's in these two chapters, or the chapter on rational expressions and rational equations. Pretty much always step one is factor everything, right? So x squared plus x really becomes x times x plus 1. Right, so x squared plus x, if we factor out the greatest common factor, really becomes x times x plus 1. Now what we're going to do is now we can start to see the factors we need. Well, this tells me I need a factor of x plus 1. Okay, so my LCD is going to include a factor of x plus 1. Now we go to the second fraction. It needs a factor of x. Okay, so let's include that in there now, x. So we have x times x plus 1. Now what about the third? The third denominator has x and x plus 1 as well, but we don't need to add more factors. We just need to make sure we have enough to cancel with each individual fraction that we're running across. So what that would look like is we're going to multiply everything by x times x plus 1, where everything's going to get multiplied by this right here. And if you like, if it helps you to think about it, because some people get confused when they're multiplying something that is a fraction times something that is not a fraction. If you like, you can just always think of this least common denominator as x times x plus 1 all over 1. right? These two things are equal to each other. So if it helps you to write it this way, to do your multiplication rate, then you should do that, okay? So what is that going to look like? It's going to look like what we had up here. Except it's going to have this fraction inserted everywhere. Okay, so do you see how what we ended up with here is I've just multiplied every fraction by that LCD, x times x plus 1 over 1. So at this point, it starts to look kind of intimidating. Oh, I'm going to have to do all this multiplication and everything? No, I mean, a little bit. But most of the time, what's going to happen is you're going to get a huge amount of canceling occurring, which actually simplifies things and makes our lives a lot easier. So in this one, I can see in the first fraction, it looks like we can cancel an x plus 1 out of there, right? And then over here, we can cancel an x out. And over here, we can cancel the x and x plus 1 out. That's great. So let's simplify everything and see what we can get it down to. So this is going to be, actually, we don't need fractions anymore. That was the whole point, right? So when the x plus 1s cancel, we end up with a 4x times x on top. So that's 4x squared. This simplifies to 4x squared minus, okay, what do we have here? The x's cancel, but it's minus 5 times x plus 1. 5 times x plus 1 equals, and then over here, the x and x plus 1 both cancel, and we're left with a 4 over 1, which is 4. Okay. So now we have eliminated the fractions from the problem that we're trying to solve, but notice what it is. We now have a quadratic equation that we have to solve. So we can do that, but we have to sort of think about what we're doing here. So let's see. We want to simplify and get 0 on one side of the equal sign. So to do that, I'm going to subtract 4 from both sides, and also I'm going to do this distribution right here. So I'm going to get 4x squared. Now distributing that 5 gives me minus 5x minus 5 minus 4 equals 0. Where did the minus 4 came from? I subtracted 4 from both sides because of this 4 over here. So the negative 4 is this 4 being subtracted from both sides. These two terms are the negative 5 being distributed in up there, and then the 4x squared stays the same. So if I simplify this, what I have is 4x squared minus 5x minus 9 equals 0. Okay. So then we have to look at this and see if we can get this factored. We should be able to, because we don't know the quadratic formula yet, so we should be able to do it with factoring. So let's see what we got. I have a hunch it's going to be 4x and x with the 9 here and a 1 here. And we want minus 5 plus 4. Okay, let's see if I did that right. Nope, what I wrote is definitely not right. Oh, I was saying something while talking, and so then I wrote it down. I shouldn't have. Okay, and this is still an equation, so equals 0. Okay, now when we set each of these factors equal to 0, because we're using that 0 factor principle that says if two things multiply together and equal 0, one of the two things has to be 0. And that's what we have, two things multiplying together here equaling 0, means that either 4x minus 9 equals 0, or the other thing is equal to 0, which is, in this case, x plus 1 equals 0. Okay, so this has been getting progressively easier. We started with this big, scary rational equation, and then we broke it down into just a quadratic equation, and now we have broken it down into two linear equations. So when I go through to do that, we're going to get okay, so what do we have? If we add 9 to both sides, we have 4x equals 9 divided by 4, so we get x equals 9/4. Or, this one is easy to solve. This is just going to be x equals -1. Okay. So we go back to our original problem and see if all of this makes sense. We have a problem. Right? Did you spot it? Well, we got a solution of x equals -1. But look what happens when I plug x equals -1 into the very first fraction. You get 0 in the denominator, which means it's undefined, which means we can't do anything with it. It doesn't make sense mathematically. It may sound like it does, but it does not make sense mathematically. So then we have to go in and say, okay, well, don't include -1 because that's not even defined. So I guess the answer is going to be x equals 9/4. That x equals -1 is what's called an extraneous solution. Okay, it's extra. It's not actually even a solution. It's like a false, it's falsely advertising that it's a solution, but it is not. Wait, where was I? Oh, it's a window under here. So what is it, 9/4? 9/4. Okay, you can see they did the same thing. They have it highlighted in green as we go there. And then you go through, you get your 9/4, and you're good to go. Okay. Okay, with that said, so there was a request for trinomials, I believe. Can you go over factoring trinomials? Yeah. Now, the thing about factoring trinomials is a big topic, and they go from the easiest problems in this chapter to the hardest problems in this chapter. So it's a little hard to know exactly where you're looking, but let's take a look. Factor trinomials, not sure what level you want to do. Feel free to tell me which level. It's like level 3. Okay, let's do factor trinomials level 3. Let's do this one. Okay, 5x squared minus 3x minus 8. Let's take a look. 5x squared minus 3x minus 8. Did I get that right? 5x squared minus 3x minus 8. Yes. Okay, so this one is not as clear cut as the simple trinomials. Remember the ones where the x squared has a coefficient of 1? Those problems are significantly easier to do. Okay, these where the coefficient in front is not a 1, it makes it a lot harder to see because it's not just what multiplies to this and adds to this. It's what combination of these four things multiply to this and add to this. And that is significantly more complicated than just the two things. So I'm going to have to play around with it a little bit. I might get it on the first try. I might not. Let's see what happens. So I know I'm going to need parentheses. Put them in there. And this is, I know I talked about this before, but honestly, write down every single part you know. People like trivialize the parentheses and go, oh no, the parentheses, that's not a big deal. Like just write it down and your brain can can release that bit of energy, not to make it sound like it's metaphysical or something, but like the part of your brain that's focusing on that particular aspect is now freed up to work on the other stuff that you're doing. Okay, so in other words, see how I wrote the parentheses down? You should write them down too. You should give yourself a little room inside to write stuff, but you should write down the parentheses. Okay, so what am I looking at? Well, I'm going to have to break up the front term and I'm going to have to break up the back term into composite factors. But here's the nice thing about the 5x squared out front. 5 is a prime. There's only one way to break it down. In other words, I know that this problem is going to break down as 5x and x. 5x squared is going to have to break down as 5x and x. That's the nature of a prime number. Now, what about my signs? This is telling me my signs are going to be different. So I'm going to have a plus and a minus. The problem is I can't put them in there yet because I don't know if the minus is supposed to come after the 5x or if the minus is supposed to come after the x. I don't know the answer to that yet. So I'm going to have to wait and see. And so we're just going to have to try things a little bit. So then I start thinking about -8. How can I break down -8? Let's see. Well, in general, 8 can be 8 and 1, 4 and 2, 2 and 4, right? So you've got those. So let's see. With a 4 and a 2, how do we get a 3? Let's see if we can do that. Oh, man. I don't usually eat lunch. I had a little chicken breast before this, and that's making me super drowsy. Let me see. I'm not seeing it right off the bat, so let me see if I can figure this out, and then I'll show everybody. So we've got 5x and x. If we do 2 and 4 won't work. So if we've got 4 and 2. What if we try 8 and 1 maybe? Oh, yeah, okay. 8 and 1 should work. Okay. So it looks like, I think this is going to work. So here I'm going to want 5x. I'm going to want this to be 5x minus 8 and x plus, nope, we want that to be x minus 1 and 5x plus 8. Let's see if this makes sense. So if I multiply this out, I'm going to get 5x squared minus 5x plus 8x. Nope, I just did that wrong. So, and then minus 8. So I had the signs right the first time. So minus plus. So let's see if we get that. All right, 5x squared plus 5x minus 8x minus 8. There we go. So now we've got this, and we're trying to factor this. So that's factored. That's fully factored now. So now we're just going to put it in. Oops. So 5x minus 8x plus 1. And we got it. So, and they give you the directions. Remember, if you miss one, read up on the directions. Try to figure out what you missed that was occurring. And they can show you the work. They can even show you on the incorrect answer. So if you ever get something that like is close and you think, I think mine's right, choose the one that is the one you think it is, and then they'll show you why it's wrong. Okay? So there you get that final answer. So we have about 15 minutes left if there's one people want to see. Any suggestions? All right, let's put a few things together. Let's do a solve trinomial by factoring. So we'll start off with the easier one, and then we'll get into the harder one. So let's do this one first. Solve this trinomial by solve the quadratic by factoring. So this is one that, you know, it takes a number of skills to be able to do this problem. We're still going to do the same basic thing that we've been doing for quadratics. It's just going to take us a little work to get started here. So x squared minus x plus 18 equals negative 8x plus 8. Okay, so we want to solve this. Remember, when there's an equal sign in that, you're usually probably being told to solve. So remember what you're supposed to do when you solve. If there's no equal sign, you're probably being told to factor. So you wanna definitely be able to tell the difference between the two things that you are being able to ask, that you can be asked to do. So if I wanted to simplify this, and remember, it should always stay an equation the whole way. Sometimes people turn it into an expression. Keep it an equation the whole way through the problem. So we need to get the things on the right to go on the left. We do that by using the addition rule, the adding or subtracting whatever we need to get those terms to go away. So I am going to, add 8x to both sides, giving me x squared plus 7x, because I have negative 1x, and I'm adding 8x to both sides, so this negative x becomes plus 7x. And then we've got 18. So if I subtract 8 from both sides, we've got plus 10. And this is where I'm saying people drop that equal sign. Let's remember to put it there, equals 0. So remember that we're doing an equation, right? Okay, so now we need to figure out how to factor this. So that's going to be what? X plus 5, x plus 2. Now remember that rule, a times b equals 0, then a is 0 or b is 0. So that's what we have here. We have two linear factors that we need to set equal to 0. And in this case, they're very easy to deal with, so that's great news. So x plus 5 equals 0, or x plus 2 equals 0, which means that x is either negative 5 or negative 2. Okay, negative 5 or negative 2. And since it's a quadratic polynomial, we expect to get two answers. So whatever the degree of the polynomial is, that's how many answers you're going to get when you solve it. So there should be two answers, and we got two answers, and that's good. So it looks like it's negative 5, negative 2. So negative 2, and then comma, negative 5. Hit submit. And we got it. Okay? So that's the basic version. You take your polynomial, you set it equal to 0, you apply the zero product rule, and then you solve for those two factors. But once you're actually doing the solving at the end, you're down to these really simple equations. Right? These are pretty simple equations. Okay, so let's go back and do solve by factoring where a is greater than 1. So this is the same idea. It's just that when we do the factoring stage, the problem is going to be a little bit more complicated for us to go through and try to figure out. So let's take this one and solve it. All right, so we have 5x squared minus 8x plus 12 equals 3x plus 10, matching the problem that we have from the delta math. Okay, so it's the same. Everything like that I say is exactly the same as what we just did. Obviously, the numbers are different, but it's basically the same problem. The only difference is the factoring that we're going to do might be a little bit more challenging than the factoring that we just did. Okay, so oops. Let's not do two things at once. So I was trying to factor and get everything on one side. So let's just get everything on one side of the equal sign. So when I do that, and how do you know which side? What if I moved everything to the right? If you end up with a negative squared term, that's going to be harder to factor. So usually we want the squared term, this 5x squared, we want that to be positive. Okay, so then we'll move these terms over to the left in order to make that work. Okay, so we're going to have what? 5x squared. So we have negative 8x, and then we already have negative 8x on the left, and then we're going to subtract 3x from both sides. So that's going to give me minus 11x. And then I've got a 12, but I'm going to subtract 10 from that. So that's going to give me plus 2. Okay, that's a good start. If I made a mistake, point it out so I don't waste all this time. Now we're going to have to factor stuff. So let's see what happens when we factor that. Okay. This one's great in that the two numbers that we need to break down are prime. So there's only a couple combinations that could even possibly work. So that's good news for us. Five has to break down as 5 times 1. 2 has to break down as 2 times 1 because they're prime numbers. So let's see. We're going to have a 5x and an x. And then let's see. What are our signs? We've got a plus here indicating they're both the same and a minus here indicating they're both minus. That's helpful. So we can fill that in. Sometimes when we figure out the signs, we don't know where they go. Like if we figure out it's a plus and a negative, and then we're like, well, does the negative go in the first factor or does the negative go in the second factor? I'm not sure. So we can work through it. We know 2 has to be a 1, so we're going to break that down one way or another. It looks to me, since our mixed terms are supposed to add up to 11, I probably want to put that 2 with where the 5 is going to hit it and give us a 10, and then we can add 1 from the other one. In other words, I'm going to do this. I'm going to put the 2 here and the 1 here, and let's see if that works. Does that make sense? Okay, 5x squared minus 10x minus x gives me minus 11x plus 2. Yes, great. And I need to make sure this remains an equation by keep writing the equal sign. Okay. You write that equal sign. All right, now remember, we're at that point where we have that zero factor rule that says I have two things multiplying together equaling 0. One of these things must be equal to 0. Okay? So that means that 5x minus 1 equals 0. Or x minus 2 equals 0. So let's see. If we solve this first one, when we get the 1 on the right, we're going to have 5x equals 1. Divide by 5, we're going to get x equals 1/5. Hopefully I don't mess that up from trying to do it in my head. The other possibility, if we solve x minus 2 equals 0, the other possibility is that x equals 2. And let's see, this started off as a quadratic. So here we don't, like, you should always check your work. It's a good idea, especially in Delta Math, where if you get it wrong, they set you back and you have to do an extra problem. But if you do your work right with polynomials, the answers should work. That's different than the extraneous solutions that we were getting with rational expressions, where we would get an answer. Remember I talked about those extraneous solutions, like what was the one we got earlier? I think it was -1. And when you plug -1 into the original problem, you get undefined terms, which means those can't be solutions because the function doesn't even make sense there, right? So we get rid of those. So let's see if I got this right. So we have 2, 1/5. See if I didn't mess this up. Nope, got it. So you can see, same thing. They start with the original equation. They get 0 on one side. Factor the polynomial on the left. Now we set the factors equal to 0. And when we do that, then we can solve each of these equations pretty easily. Okay, more easily there. Okay, so that's how you do those. Any other questions? I think we got time for one more problem. If people will have something they want to see, I'm happy to go over it. So now's your chance to get a little help with the homework that's due tonight. What can I help you with? Hold on one second. Okay, sorry about that. So nothing? There wasn't anything that anybody wants to see? Nothing? Oh, here we go. Can you also go over greatest common factor? Sure. Let's take a look at that. Great. That's common factor multivariable. Okay. Greatest common factor multivariable. Okay, great. Okay, good. So we can do this one pretty quickly. So that's good. So here's the question. How do I break down the greatest common factor for something like this? So let me put it over here where I can write it and mess with it a little bit. Okay, so we've got, what do we have? 50 x to the 6th y squared z to the 4th minus 10x squared y to the 6th z to the 5th. Okay, so this we have to factor. Now, this looks intimidating and scary. It looks like, man, there's so much going on. How am I supposed to like keep track of everything? And the key is you focus on one piece at a time. So each of these terms here is really composed of 4 pieces. There's the coefficient out front, there's the x variable, the y variable, and the z variable. And you only have to look at one at a time. So break it up into 4 steps, not one step, right? I see students do this where they're trying to stare at everything at once. And it's like, you're not going to be able to do that. Okay, so what you want to do is first let's look at the coefficient. 50 and 10. Okay, what's the biggest thing I can pull out of 50 and 10? It's a 10. So I'm going to pull out a 10. And when I pull out a 10, that's going to leave me with a 5. And then the 10 is out from the other piece. So we're going to factor out a 10. Okay, what about the x variable? We have an x to the 6th and an x squared. Well, the biggest thing that we can pull out from both terms is actually the smallest variable that occurs. That sounds confusing. People go, the biggest thing we can take out is the smallest variable that occurs? Yeah, because here we have an x to the 6th, here we have an x squared. If this term only has an x squared, we can't take out an x cubed. That's too big. This one doesn't have an x cubed, only x squared. So we're going to pull out the x squared here. Okay, so that's going to become x squared. And when we pull out the x squared, here we're going to be left with 4 of those x's. We're dividing x to the 6th by x squared. That's going to give us x to the 4th. Okay. And in the second term, we factored out the whole x squared, right? Okay, now it's like the tables are turned. Now the roles are reversed, where we have the y squared in the first term and the y to the 6th in the second term. So now we're going to take out a y squared. But that means over here on this one, we're left with no y term. And over here, we have y to the 4th. And now what about our z's? Well, I have z to the 4th in the first term and z to the 5th in the second term. So the smallest of those is z to the 4th. So I can factor out a z to the 4th, even though I typed x on accident. Okay, z to the 4th. And that leaves me over here with no z term, but over here we're left with a single z term. And we usually don't write z to the 1. We're just usually going to write that as z. Okay, so let me just double check this and make sure it looks right. How do you know if it's right? If you multiply everything back out and you get what you started with, then it's right. Okay, so let me see. Yep, that should be right. Let's see, all we had to do was factor, right? Okay, so I'm going to bring this back in. That's going to give us 10x squared y squared z to the 4th. Oops. Y to the y squared z to the 4th. To get out of that exponent, you just hit, use your arrow keys to either go over or down, and it'll get it out of the exponent. So we've got this, and then that's going to be what? 5x to the 4th minus, I think we decided it was minus 4 minus y to the 4th z. Okay, minus y to the 4th z. Yep, and there we go. So it's just, and you can see how they did it here. See how I talked about taking it one piece at a time? That's what they're doing here. The number GCF is 10. The x GCF is x squared. The y GCF is y squared. The z GCF is z to the 4th. Don't try to do all 4 of those at once. Your brain's just going to get scrambled. Try to do them one at a time. And then you put them all together, and then we just factor that. That gives us this, right? Notice that this thing in front is all of these combined. The 10, the x squared, the y squared, the z to the 4th. It's literally these things right here. So you've got that. You divide it out from your original stuff. You get this, and then it's simplified. Okay? So that's how you do that. So yep, just be aware you got those due dates. If the due dates pass, you still can work on the problems you didn't get done for half credit, but who wants to do that, right? Who wants to basically get paid less for the same work, right? Try to get full credit for it if you can. Other than that, I'm going to turn off the YouTube stream, Anyone who wants to chat with me is welcome to do so in Zoom. Otherwise, I will see you in a week. Okay, thanks everybody.